All right, so the last type of combinatorics and statistics that we are going to look at is going to be combinations, okay? So what is combination? In many problems, we are interested in the number of ways of selecting our objects from n without regard to any other. These selections are called combinations. In other words, a combination is the selection or arrangement of n objects or a finite object taking r object at a time without any specific order. Okay. So for example, the number of ways three different books A, B, and C can be arranged without any order in a shelf, taking two at a time can be done in the following ways. So we can have the first arrangement can be AB, right? We can also have AC or we can have BC, okay? So yeah, the order of arrangement is not all that important to us, okay? All right. So the question is, what if we have, let's say, 1,000 books or 505, what do you call it? 500,000 or 1 million books, and maybe you want to arrange these books in a shelf, taking, let's say, 100 of them at a time. Are we supposed to list it in this form? This may be very tedious. Okay, this is good if maybe the objects are very small, okay, but if the object that you're dealing with is very large, then there is a better way to actually work with combinations instead of trying to list it in this form. So let's take a look at that general form. So in general, the number of combinations of n distinct objects taken r at a time is giving us n combination r. This is n combination r. In other words, you can also say that this is n choose r, okay? You can express it in this form, n choose r, which can be expressed as n factorial divided by r factorial multiplied by n minus r factorial, okay, where n is greater than r, okay? All right, so the combinations of the three books taken two at a time can be done in three combination two or three choose two. It can be expressed as 3 factorial divided by 2 factorial. 3 minus 2 factorial is 1, so we have 1. So we have 3 factorial divided by 2 factorial, which will give us 3, right? So we have 3 ways of doing this, okay? All right, so let's take a look at a general example. From 4 chemists and 3 physicists, we want to find the number of committees that can be formed consisting of 2 chemists and 1 physicist, okay? So the number of ways of selecting 2 chemists from 4 is going to be 4 choose 2, right? So this is 4 factorial divided by 2 factorial, 4 minus 2 factorial with 2 factorial. So you are going to obtain this. And once you compute this, you're going to get 6, okay? Also, the number of ways of selecting 1 physicist from 3, right, is going to be 3 choose 1. It can be expressed in this form. Okay, you also obtain this, which is going to be 3, okay? So the total number of ways of forming a committee with 2 chemists and 1 physicist is going to be 4 choose 2 multiplied by 3 choose 1, which is 3, and 6 multiplied by 3, which is going to be 18. So this is going to be the solution for this example, okay? All right, this is a trial question. I'm going to leave the solution in the description of this video so you can check it out. Please, if you found value in today's tutorial video, don't forget to subscribe if you have not, and thank you for watching.